Hello Internet, welcome back to the world of Zero Arcade. In this video, we are going to be working on building out some more of the services that are needed for this. So I've actually finished completing the architecture for how players are going to connect to our game. We're going to start implementing some of those bits. I'm planning on doing a video that will showcase the entire architecture like from a high level and how everything is going to kind of play together. We're specifically going to be looking at our player service right now. So that's going to be a service that players will connect to and say, I want to play the game. And then what we're going to be focusing on is they are going to enter a username effectively into this, and it's going to put them into a queue. And effectively, they're going to have to continue to send keep alive messages to this in order to stay in the queue. So we're just going to start with a quick ASP.NET Core application. We've done this before, so there's nothing too fancy going on here. I've just got the default thing. It's actually the exact same default we had when we were doing DataCube. So there's nothing outstanding there. What we're going to be working on is actually making a queue. So we're going to create a post here. So I'm going to create a new controller. It's going to do its whole dependency thing again, which I should have done beforehand, but I didn't. So what we need to do is we need to insert players into a queue. And so that's going to be who's up next as a queue. And then there's going to be some sort of keep alive that the controller is going to have to, or the remote is going to have to send to the service at like a constant ping, just to make sure that they are still active. We're not going to keep a persistent connection to that because I feel like that's probably not the best way to do this. So depending on the number of people connecting to this, there could be a lot of those. And I don't necessarily think that it's a good idea to open up a persistent connection to all of those. And also, we're designing this as a separate service, not as part of our game. So this service can be hosted anywhere. Could go out on like Azure or the Google Cloud or AWS or something. I'll probably host it locally for at least initially, and then post it out to a cloud service later. But this way we can kind of separate it off and do that without interfering with the game. So if this service gets like DDoSed or something, the game itself is going to be unaffected. You just won't be able to get any new players. So that's sort of the idea here. That's why we're doing it the way we're doing it. It avoids any of that other annoyance from just tying all those two systems together. So we need to create a player controller, which is going to handle enqueuing players into our queue. And then we're going to need to persistently check that queue and say maybe every 10 seconds or so, if they haven't checked back in, we'll disqualify them and remove them. And we can have our remotes check in significantly more than that and just keep pinging, which isn't super efficient, but it prevents opening those persistent connections. I don't know which is better. We may have to test both, but we're not to that point yet, so it doesn't really matter. I'm going to steal the post from here. So there's a post method. I'm just going to copy and paste that in here. And this is going to, let's actually rename this to like create or enqueue player. So we're going to enqueue a player into our queue, I guess that's what we're going to call it. So we've got our enqueue. We're just giving it a string. That should work for now. I'm also going to want to create our PlayerQ. So the way we're designing this, let's just call it our queue. But the way we're designing this is so that anybody can kind of connect to this. So the queue could theoretically be some entirely separate data structure. It could actually be a totally separate service. It doesn't really matter. We just need something that holds a list of players and can select from that list who's up next. The easiest implementation is literally just a queue. So that's what we're going to be starting with. We can change it later. And because we're using a queue here, it can get a little bit funky. because iterating over a queue is going to pop everything off, which we don't necessarily want. So I think the best way is actually to use a linked list. So that'll give us constant inserts and deletes. And we just need to iterate over everything, so that should be fine as well. There's nothing exceedingly difficult about that. And we're just going to store, we need to store the time that they last checked in and their name. So let's create some sort of data structure for this. I'm just going to call it, good question. We'll call it our player waiting model. That sounds like a terrible name, but we're going to go with it. So we're going to do just a public. I'm going to do this really quickly because this part doesn't particularly matter for what we're building. What we're building is a queue that can kick people out of it. So we need a public string, and we're just going to do player name, like so. And we need a string, or a date time actually, of our last check-in. And just for good measure, I'm also going to store our initial check-in. So this will be the first time we received a message from this client. So what's going to happen is we're going to create this player. Initially, the last check-in and the initial check-in are going to be the same. And then every time that player, that remote, is going to ping and say, hey, I'm still here, we'll update this last check-in, and that's what we're going to be checking. If for some reason we need to like rebuild our queue, we can do that from this initial check-in without any issues. And that should keep everything working, I think. So we've got that there. Let's do a linked list of those. So player waiting model, and we'll just make that private and make it our queue. We can just initialize it here because that's fine. Let's enqueue something. So we're going to just do a void enqueue, and we're going to just enqueue our player. Actually, enqueue or update. So this is going to iterate over it if it doesn't find it. So this is in O of n just because of the way it's working. But we're going to iterate over our entire list. If we do not find what we're looking for, if we don't find our player, then we're going to post, we need something else. Actually, I think, so we're going to have a lot more people checking in than we are going to be pulling people off, because we're only going to pull one player off every time they lose, at least with the current game. And that's going to be like a very minimal operation that only need, and if it's delayed, it doesn't really matter. So we can actually use a dictionary here, keyed on our player name. So we're going to key it on strings. So this is going to be a little bit weirder. But what we're going to do is key it on the player name. So we're just going to have a player here. And what we're going to do is this initial string, that's the player name. That's what we're looking for. And then this player waiting model just stores all the data about the player waiting in the queue. So that's going to have all their time waiting and stuff. And so this way we can get, since this is a hash map behind the scenes, we can get actually O of 1, which means we can get constant time lookups into this in the best case, which is really good because it means that when I do this, which theoretically these pings are going to be happening constantly, so we'll get, if we do it every like 2 seconds, the number of clients in here divided by 2 is the total number of pings per second we're going to get. And that can get, it's not going to get high enough to destroy our server at any point, but it could get pretty high. So we're going to do it this way. This gives us O of 1 instead of O of n, significantly better time. And that should solve this. I went on a big ramble about O of n and amortized time and all of that. I've never actually done a video on that, so if you guys want to see that, let me know in the comments. I don't know how well I can cover it, but if it's something you guys want to learn more about, let me know. I can at least find you resources. So we need to check our queue. So we're going to if queue.contains key, we're going to try to see if the player already exists. So if the player already exists, this probably is not the best way to do this. We're going to probably want an ID. Again, that's not really relevant to what we're trying to do. We're trying to do a queue that can get rid of people. So we're not focusing so much on how we're identifying people. We just need some way to identify them. I'd probably stick an ID in here instead, just so people with the same name don't like all just refresh everybody else's and never actually get in. So if our queue contains a key, we've got this, if our queue contains our player, then we know they already exist. So we're going to do a queue dot, and we're just going to get our player. So we can just, this is an overrided dictionary function, so we can actually just look this up and do the last check-in is equal to datetime.now. And that's it. We just need to update when we last checked in. And then otherwise, if there's nobody in our queue, we need to enqueue that player. So we're just going to add them. Add. We need to add a player and then a new player waiting model. So we're going to give it a player name equal to our player. And then our next two values are just going to be our date times, the current date time. So this will be just datetime.now. And the initial check-in will also be datetime.now. And this way, we have when the player checked in. This is never updated, so we don't need to worry about that. We have our last check-in, and we have our player name. So all of that is created if the player doesn't exist. Otherwise, we just update their last check-in and do all of that. So our final thing, we're going to need void remove old. That's a really bad idea. And we're actually going to take a time span here. So we're going to remove everything that is greater than the time span. So the difference is going to be datetime.now minus the last check-in. And if that value is greater than the current time span we're passing in, so we'll just call it a time span, then we're going to remove it from our queue, which is going to be a little bit funky. We're going to do a for each loop here, so you can't actually just remove things like that. I'm actually going to make that easier, so we're going to just use var here. It just implies the type. Local variables only. Okay, never mind. We're going to use it here. So this is just going to be our to remove. So we just need to temporarily store all of the things we're going to remove in a temporary linked list. And we just need the keys here. So I'm just going to store the strings of the player name, and that should be it. And then for each, we're going to grab every player in our queue, the PlayerWait. We are going to pull out all of those and stick them into the to remove. Actually, we can do this with link. So to remove can equal our queue dot where the player, that'll work, where the player dot value. So we want to get the value of this. Since this is a dictionary, we have the string, and then this player waiting model is our value. We want to use our last check-in and subtract that from the datetime.now. So datetime.now minus this is going to give us some sort of value. And then we want to just say if that's less than or equal to our time span. So if it's less than or equal to the current time span we specified, then keep it in. Actually, greater than, sorry, because these are the ones we want to remove. So we're just selecting everything we want to remove. And then for each thing to remove, we just need to actually pull it out of the list. So var remove in to remove. This is kind of gross, but we can deal with it later. So we're going to do a Q remove, and we're going to remove our value. This is not the value. Let's stick a select on here. And let's just take the player name. So we'll actually just take the key. So all we need is the keys here. So we're going to just, first we're going to filter our list. That's what this where is all about. And next we're going to actually take this select and only select the player key, which is what this is doing. So this to remove just contains the keys of the items we need to remove. Then we go into here and remove them from the list. So we can just use remove. And that should pull them out of our list. And that's that. That's all we need to do. So now all we need to do is throw together a really quick function or thread, I guess, to actually pull this out. So this PlayerQ, I'm going to just create it here. So we may want to use some dependency injection later to actually throw this PlayerQ in to this object, but for now, this will work. So I'm going to create a private PlayerQ. There we go. And we'll just call it the Q again. We can just instantiate it like that. There's nothing fancy going on there. And then our NQ is just going to be a Q.NQ or update of our value. So we just pass in, this value is going to be the player name. And then we need to spin up a really quick thread that's actually going to do that check to actually remove all the old things. And then the last thing we need, there's one more, is we need to be able to get all of the players that are currently active. So we'll just return a enumerable string list. So just a list of strings. So we've got our strings there. We need to get, sure, we'll call it just get for now. That's a really bad name, but it will work. And all we need to do is return our Q.select, and we really just need to select the player key, because all we care about is the name, and that's all that's there. We don't care about all that other stuff. That's just back-end stuff. We don't need to expose that to anybody. That way we can change it without breaking everything. So there's no dependencies on that stuff. So this is going to throw out a list of all of our players. So all we need to do is expose that to all of our other consumers. So I'm going to create a get here. Void get players. Don't need any arguments. We can just literally return our Q.get. And then this return type, it just needs to be an enumerable string list. So ASP.NET is automatically going to convert this into JSON. So it's going to look like a JSON array of just strings. So there's nothing fancy going on here. It's just doing that. Wow, actually, it is fairly fancy. There's a bunch of converters going on, but the end result is this gets passed through a converter, which gets you JSON of whatever you pass in, which in this case is an enumerable string, which should work. So all we need to do is throw together a player controller that is going to start some sort of background task. So I'm going to store that task here. We may want to move this somewhere else later, because this is going to be gross for now, but it'll work. So we're going to create a new task. Let's not do it that way. Let's do a task.run. And this is going to expect some sort of lambda to run. I think actually we can just use a timer. Timer. There we go. So let's plug in a timer here. There we go. There. So we want a new timer. I don't know if this is the exact thing I want, but we're gonna find out. No. Is there a dispatcher timer? So I don't know what is actually available to ASP.NET compared to like WPF. WPF would have a dispatch timer because it needs one. A dispatch timer would actually invoke the UI thread when it calls its timer. This one won't. And I don't know if this uses tasks or not. I would assume no. So we may not want to touch that. Let's just do a task, sure. Sorry, I'm kind of making this up as I go, so we'll see how that works, but we're gonna do a task here. So we need a task, we're going to run it, and what this task is going to do is it's going to be an async, so we're gonna make it await, or async, sorry. Mark it as async. This allows us to call awaits inside of this function. So the first thing we're gonna do is task.delay. So this is effectively the thread.sleep function, but it's for a task. Very important note, do not call thread.sleep inside of tasks because there could be multiple tasks on a thread, and putting the thread to sleep will put all of those tasks to sleep and not just the one. So you can get some very weird behavior if you do that. And it's not good. Try not to mix the threading stuff or the threads with the tasks. If you're using tasks, stick to tasks. If you're using threads, stick to threads. That's the best I can give. Here, we're just going to delay it by about a second. Sure. Ideally, we'd probably set up some sort of time or callback and have it constantly saying, oh, this one just expired or this one expired, so we can know when is the next one going to expire, so we can actually just track that and only fire the timer when that time should happen and then move it back and so forth. We're not doing that here. This is just brute forcing it, which probably not the best solution, but it's a solution. So we're gonna do it. All we need to do is actually remove it. So time span, we're gonna say if it's older than 10 seconds. So my camera just died. That's nice. Okay, I really need to figure out how to make my camera not do that. I don't know. Anyway, so we have our queue, and this is just going to remove things from our queue that are greater than 10 seconds old. So if there's something that has not seen a check-in within 10 seconds, it's going to be pulled off. I'm going to probably keep it for 10 seconds now. We'll probably up that to like 30 seconds or so, just in case like somebody needs to restart the computer quick or something like that. We don't necessarily want them to lose their position in the queue, especially if it's between games. Really, this matters a lot more right around the time of a game when somebody's saying, hey, I need a new player, are they available? And that we can actually handle in the game itself. This will just be a way to actually pull people off of that and check that. So I think this is good for testing. So let's actually do that. I'm going to need Postman for this. So what we need to do is test a post to this URL and then test a get, and we should see our player there. And then we should wait 10 seconds and it should disappear. That's the expected behavior. And if that's working, then we succeeded and we've created a queue of players that actually exists and then doesn't exist. So this is going to fire up in its shell. We can actually do API/player. So let's open that, API/player, and we'll get an empty set. So this is working. There's just no players there yet. So we can keep this open. I'm going to go open Postman, and then we should be good to go. So 1 second while I get that. So I've got Postman. Postman's just going to let us post to our URL. Web browsers are really good at getting things, but there's a lot more that you can do with the URL. So we need the post. We specified that in our ASP header or annotation. That's a Java thing. Anyway, we told it we needed a post and that the body would include a text string. I don't actually know how this is going to expect it to be formatted because we literally just gave it a string. So I don't know how this is going to work, but we're going to find out. So let's say I want to pass in RuneWake 2. Unsupported media type. Let's switch it to JSON and send that. Value cannot be null. So we passed in a null value. Oops. So that's going to break things. So there's a giant stack trace. That clearly doesn't work. So let's try. This is going to be gross. But I think we should be able to just do value. So let's create a actual JSON object that looks like this, and actually make it a string. So we've got the value is equal to RuneWake 2. Send that. Value cannot be null. So obviously, this is telling us we need to validate our data because we're not doing that. So, I was not expecting this to be the struggling point. Let's see. I don't actually know if this works, which was why I was trying those different things. But since it is apparently broken, let's create a very simple view model. So we're going to do a player view model. And it's literally just going to be public string name, and that's it. So we're just going to pass in the name. That should work, right? So we give it a value and pull out the name. We have to actually include a using for that, but this should solve all of our problems. The only thing we need to do after that is change this value to be a name. Whoa, don't want to save. So that has started up. We can send it, and we get a 200 OK. So now I can go back here and refresh, and it's gone. Okay, that should have worked. Let's throw a breakpoint and see where we are. This was supposed to be super simple, and I'm really annoyed that it's not working. So we'll send it, we'll hit our breakpoint, it will get stuck. We can... No. There. Okay. Let's see, does it contain the key? No. So this should go to add it. It adds it to our queue. And then we continue. So if I do a queue.get, how many things are in? Nothing's in our queue. Why not? I don't... Oh, wait. No, that's right. Hold on. I don't understand this at all. I've screwed something up, and you guys probably know what it is, and I have no idea. We have a dictionary. We're pulling out all of our keys. So that should get all of them. If there's anything to remove where the time span or where this difference is greater than the time span, then select their key and remove them. But I don't think this is ever actually getting called. So we've broken it in two places. Our Q is lying to us, and our adds aren't actually working. I think I can... Ooh, that wasn't what I wanted. If I go here, since I paused it, I should... never mind. Can't see those values. This was supposed to go very smoothly. And it hasn't. And I don't know why. Good question. So I think what we're going to do, I'm going to stop this. It's clearly not working. I think our add, we know that add is working. We dropped a breakpoint, we saw it add it to the queue. What we don't know is going on is whether this is broken or this is broken. I'm thinking it's probably this. Because we're just returning the selected keys. I'm actually going to stick this in a 2 array. So this will just force the evaluation of that. Link statements are lazily evaluated. So if you... The way I had it was fine because nothing was actually... We were just returning this and serializing it. But the problem with link statements is they're evaluated every single time you call them. So if we did this get and then did like 3 things with that result, we would iterate, or we would do this entire statement 3 times. So by adding that array to array, it should solve that issue at least. It's not going to fix the broader problem of this not working. Don't know what's causing that, but we're going to find out. So our toRemove is never getting called. Removal just doesn't happen. Something's broken with our task. It's not happening. So, what? Oh, because it's the first time we called this player, or this controller, so it actually has to create this, and then it runs it once. That was supposed to be in a loop. That might be part of the problem. So there's nothing in our queue. So I can just ignore that. Then we're going to post our player out to our service. It hit that breakpoint because we're looping, remember? Oh. Ha. I get it. So, in case you missed that, we hit this breakpoint again, this await task delay. That means we are creating this entire controller every single time we call this. I'm not sure why that's happening. I think that's probably not supposed to happen because that sounds very resource intensive and bad. But the entire constructor is recalled every time we call this, which explains why our queue is always empty, because we're creating a new one. We can solve that though in the worst way possible. We're going to make it static, and we're going to move this out into a static constructor. So if you've never used these before, they are constructors that automatically fire. Oh, I need to static. I've used these in Java, never in C# before, but I think they exist. Pretty sure they exist. This is a thing, I thought. Let me check this quick, because I want to use one of these, because this will at least move us forward. I was close. Let me close that. So this is a static constructor. The syntax looks like a normal constructor with the static keyword in front of it. What this does is the first time you call this class, it runs this static constructor. So you can use this to initialize like static variables like we're going to do. So this remove task, we're going to initialize it that way. And since it's static, it's only going to get called once. So static constructors are super useful if you need to initialize static stuff. I don't recommend using them too often because this is weird and you don't have as much control over when things are created as you might want, but they're cool. So the first time we call a player controller, it is going to automatically create this static thing, which should start our remove task, which should start firing. I'm going to stick this in a while true loop because that's just what we want to do. Probably also not a good idea. But this is just going to loop. It's going to wait for a second and then test and then wait for a second and then test. We're going to want to pull out the breakpoint we had here because otherwise we're going to hit that constantly. And that's no fun. So I should be able to fire this up. Our static constructor should fire the first time we instantiate this thing. So it should fire right. Let's drop a breakpoint just to be sure that I'm not making this up. But when I refresh this, the first thing that happens is our static constructor fires off. This will start our timer. So it won't even be running until we've gone to this endpoint. But it should never get called again. And that's important. So you're never going to see this static constructor get called multiple times in a single execution of the program. So if you need to do something once and exactly once and only when something is used to initialize something, that's how you do it. Then we're doing a get, so we're just going to get nothing, which is super interesting. Don't really care about that. I'm pretty sure we've solved the problem, so we don't need to worry too much about anything. I'm going to throw this in here. We're going to hit breakpoint, just make sure our name is correct. It is. And then we can call this one more time, do our get, continue, and we get RuneWake2 as the first player in our list. So if we wait about 10-ish seconds, this loop should constantly be going and should eventually evict our character from our list. So I can actually just remove that breakpoint and just start spamming this. And he's already gone. So after 10 seconds, they just get kicked out and they'd have to rejoin. So if I resubmit it, they end up right back on the list, but they would be at the end. Well, they'd be wherever we put them. We didn't do any sorting, so it's not technically it's not a queue. It's more of a hash map with the ability to find what time things were inserted at. So this probably isn't the most efficient data structure for this, but it gets us. What we were trying to do is get constant time lookups for the player, because that's going to be what happens the most here. Maybe once or twice, maybe once every like 5 minutes, we get a queue or query for what the next player is, but that really doesn't matter. That's once every 5 minutes. This update of the player, that's going to happen a lot more. So we want that to be our priority. So that's what we do. So anyway, this is working. We have our queue. We're going to work on expanding this a little bit and making this a little bit more useful. Eventually, we're going to have our game be able to pull from this service and get the next player to actually pull in. and then they'll handle actually connecting and doing a bunch of the final validation. And if it doesn't work, they may kick them back onto the queue or something else. So that's it for this video. If there's anything you guys want to see, any feedback you have, I'd love to hear it. If there's any ideas you have for where to take this project, I'd really love your feedback on that, because I'm kind of making this up as I go. And so if you've got an idea for like the game or even how this should all work, I'd love to hear it, because I've never done this. So yeah. But until next time, see you, Internet.